This shouldn't work, I promise you. That wasn't editing. Okay, fine, it was editing. But if the knife can defy physics for dramatic effect, maybe an orange can too. Today we're testing a very strange question. Why does an orange float? Until you peel it? No magnets, no tricks. Just fruit and science. So here we have two perfectly normal oranges. One of them stays fully dressed. The other one, unfortunately, is about to lose its jacket. If oranges had HR departments, I'd already be in trouble. All right, 2 glasses of water. 2 oranges. Now here's the part that confused people for a long time. You'd think the heavier orange would sink? Right, let's find out. Down it goes. Straight to the bottom like it owes the water money. But the unpeeled orange? Drop second orange, it just sits there, floating. Like it's on vacation. Now wait a second. That doesn't make any sense. The orange with the peel is actually heavier. So why is the heavier one floating while the lighter one sinks? Let's poke it, no strings. Just a very smug orange refusing to sink. So the only real suspect here is the peel. Let's test that. We're taking the jacket off. Again, sorry, orange. Now, if the peel is the reason it floats, something should change. And there it goes. Straight down, case closed. So clearly something inside the peel is acting like a flotation device. But what exactly is in there? This is where things get interesting. Let's zoom in. Under the microscope, the peel looks completely different. Instead of smooth orange skin, we see a landscape. Little yellow and orange bumps everywhere, almost like tiny craters. Or pores. Each one of these bumps is actually a tiny pocket filled with oil and air. Millions of them. And those microscopic pockets trap air inside the peel. Air is much less dense than water. So when the peel is attached to the orange, it acts like a built-in life jacket. The orange isn't magically floating. It's wearing a flotation device made of microscopic air pockets. Let's prove it, just the peels. And look at that. They float. Exactly like we expected. So the mystery is solved. Orange peel equals flotation technology. But we're not done yet. Let's try something weird. Here's the peeled orange again. No peel, no air pockets. Which means drop orange. Right back to the bottom. But watch what happens if I do this. Swirl water with fingers. By spinning the water, we create a tiny current that pulls the orange upward. And suddenly, the orange rises. Not because it can float, but because the moving water is carrying it. Which means 2 things are controlling this whole experiment. Density. Trapped air. So next time you eat an orange, remember this. That peel isn't just protection.